Fleming's left-hand rule or Fleming's right-hand rule, which hand do you use? This seems like a very easy and straightforward question, but it's quite difficult. So first, let's start with understanding where Fleming's left-hand rule actually applies. So this applies in motors where a force is experienced due to the motion of current. We know that whenever current flows, it's going to create a magnetic field. And if you were to take a piece of wire, place it in a magnetic field where you have two separate magnets, that wire is going to experience a force. So Fleming asked himself a question: in what direction is that force going to be acting in? So in order to figure that out, we're going to use Fleming's left hand. So the thumb represents the force, the direction in which the force is going to act. The second finger represents the magnetic field, the direction of the magnetic field, so it's B. The last finger represents the direction of current, so F, B, I. That's basically how you're going to use that. So if you're going to point it, point wherever the magnetic field is acting, point wherever the current is, and then the thumb itself will show you the force. Either it's going to move up or down. So that is where we use Fleming's left-hand rule to figure out where would the wire move if we were already to take it and place it in a magnetic field. Fleming's right-hand rule, however, is mainly used in generators. This is where we have objects that are moving and then electricity is generated. So current is induced in that particular wire, which is so different from a current present causing a force to act. So in this particular scenario, you want to figure out the direction of the induced current, which is conventional current, by the way, which is current that moves from positive to negative. So you want to figure out in what direction is that going to act. That's when you're going to use Fleming's right-hand rule. How does this work? Again, you take your thumb. The thumb shows you the direction of motion, right? If you were to move it in this direction, it's going to experience this kind of induced current. The finger still shows you the magnetic field, right? And then the other finger is going to show you the direction of induced current. So because of that, I'm going to point like so. That means the induced current is going to act in that direction itself, and the original current is going to act in that direction. So the two are opposing each other. That's the difference, right? Fleming's left-hand rule helps you identify the direction in which the force is acting, and you use it when you have current already present and the object itself is moving and you want to figure out the force. And Fleming's right-hand rule, however, is only used in generators where you want to find the direction in which the induced current is going to flow in based on a particular motion that you have induced. That's the difference. And by figuring that out, you can be able to solve a lot of problems that you will be able to encounter.